We have here the function y equals cotangent to x, and we are tasked to find its derivative using the four-step rule. First thing that we have to do is to substitute y to y plus delta y and x to x plus delta x. So that would be our first step. Y plus delta y equals cotangent of 2x plus delta x. Next, the second step would be to solve for delta y. To do that, we just have to transpose y to the right side. To the right side. So that would give us delta y equals cotangent of 2x plus 2 delta x minus y, or cotangent to x. Next, the third step would be is to divide both sides by delta x. That would be the third step done. And lastly, for the fourth step, is we'll find the limit of the function as delta x approaches the limit of the function as delta x approaches to 0. So that would give us cotangent 2x plus 2 delta x minus cotangent of 2x over delta x. Next, we just have to evaluate the function with the limit. First thing that we have to do is to evaluate everything to sine and cosine, which would give us cos 2x plus 2 delta x over sine 2x plus 2 delta x all over, or minus cos 2x over sine 2x all over delta x. Next is just we have to evaluate this operation. Try to subtract this thing and this thing. And to do that, we just have to find the LCD of both terms, which would be sine 2x plus 2 delta x and sine 2x. That will be a denominator, and we divide our denominator with the first term and multiply to the numerator, and divide the second term as well and multiply it to the numerator, which would give us sine 2x multiplied by cos 2x plus 2 delta x minus cos 2x multiplied by sine 2x plus 2 delta x. And this is all over delta x. Now to divide delta x, we just multiply the fraction above to its reciprocal, which is 1 over delta x. After that, if you can notice right here, we have here the sum identity of cos, the sum identity of sine. What we have to do is we just have to expand those identities. So we'll be given with sine 2x and cos 2x cos 2 delta x minus sine 2x sine 2 delta x minus cos 2x sine 2x cos 2 delta x plus cos 2x sine delta 2 delta x. Is that sine 2 delta x? That is all over delta x multiplied by sine 2x plus 2 delta x sine 2x. Next, what you have to do is to distribute sine to x to this and to this, and cos to x to this and to this. Will be given with sine 2x cos 2x cos 2 delta x minus sine squared 2x sine 2 delta x minus sine 2x cos 2x cos 2 delta x minus cos squared 2x sine 2 delta x. That is once again all over delta x sine 2x plus 2 delta x sine 2x. X is we just have to combine like terms, and you can see that in sine 2x cos 2x cos 2 delta x and negative sine 2x cos 2x cos delta x. And then we will be left with negative sine squared x, negative sine squared 2x sine 2 delta x minus cos squared 2x sine 2 delta x all over delta x sine 2x plus 2 delta x sine 2x. Now, we can't just substitute delta x with 0 because this would make our function undefined. So what we want to do is we want to find, or we want to find a way so that we can get squeeze theorem or use sine x over x that equals to 1 and 1 minus cos x over x equal to 0 in our function. But this time we can just ignore cos x because we're only dealing with sine x. So to do that, we want to multiply 2 to delta x, and to make it possible, we have to multiply the numerator with 2 as well, so that this would be cancelled, or this would be equal to 1. But in this case, we will be cancelling that so that we can get sine delta x and over delta x. Now, where can we get that? Let me just copy paste this. Just a second. Paste it here. Now, first, we have to factor out sine 2 delta x, the numerator, because once again, we want to cancel that. So that would give us with negative sine 2 delta x multiplied by sine squared 2x plus cos squared 2x multiplied by 2 all over 2 delta x sine 2x plus 2 delta x sine 2x. Now, if you can notice, this is also an identity, which is the Pythagorean identity, which equals to 1. So basically we can cancel this out now because it just equals to 1. And if we factor out the negative sign here, we will be given with sine 2 delta x over 2 delta x. So we can cancel this as well. Now we will be left with negative 2 over sine. Oh, this is squared. Apologies. This is squared. Oh, wait, no, that's no, no, no. That's a sine. Okay, apologies. That's sine 2x plus 2 delta x multiplied by sine 2x Now, we can now evaluate, or we can now substitute 0 with delta x, which would basically eliminate this, and we will be left with negative 2 over sine 2x multiplied by sine 2x, which is also equal to negative 2 over sine squared 2x. This would be the final answer, but we can simplify this further using the reciprocal of sine, which as we know is cosecant 1 over sine, and cos has secant 1 over cos. We just have to substitute this, so that would finally give us with the final answer as negative cosecant squared 2x multiplied by 2. And that is the derivative of y equals cotangent 2x.